Okay, we're going to do a quick review of motion and the equations of motion that we had learned last year. So I don't have a PowerPoint that goes with this, so I'm just going to ask that you jot down some notes as I'm kind of going through this, and also that you have your problems packet that I gave you, the homework, that you have that out and ready, because I probably am going to work the motion practice problems, by the way. I'm probably going to work a couple of those. Anyway, so let's go ahead and get started. Let's just kind of review what we can remember about motion and how we went ahead and defined motion. There were three variables that we really dealt with. One of them was the position of the object. We had to know where the object was located, and we usually gave that a symbol of X, or if it was a horizontal position, or possibly Y if it was a vertical position, if we were talking about something moving up and down. But that position would be a function of time, and you would have to, depending on what the object was doing, you would need to know what the function was. Then we talked about the velocity, or how fast the object was moving, and its direction, and the symbol we used for that was a V. It's a vector. By the way, position's a vector too, so we'll put vector symbol over the top of that. So velocity is a definition of how fast and direction, and the direction that it goes with. And where I think you guys are pretty familiar with velocity vectors. The last piece of this puzzle was acceleration, and that was the rate at which you change your velocity. The symbol we used for that was the letter A, and you're pretty familiar with that too, the units meters per second squared. And then we had some equations that related all of these particular variables together, and those were called the equations of motion. And these come in lots of different, how you look at these, they come in lots of different forms, but I'm going to use the forms that are probably most common. So the first equation talks about how the final position is equal to the initial position plus v initial times time plus 1/2 at squared. So that's one of your equations of motion. Another equation of motion deals with v final being equal to v initial plus acceleration times time. Hopefully these are coming back to you if you can't remember them. And then the last one was a nice one because it didn't have time in it. V final squared is v initial squared plus 2 times acceleration times displacement. Now displacement is, by definition, from start to finish. It's where your starting position to your finishing position. That straight line vector from start to finish, that should be a straight line, is your displacement. So we define that as the subtraction of the two positions, but it's a vector subtraction. So those were our equations of motion, and we did lots of problems with those last year, and there's going to be lots of problems on your worksheet that go with those equations of motion. So I just want you to bring those to the front of your mind when we deal with those. And remember, they each served their own purpose. Some of them have time in them, some of them don't. They might have, this one here doesn't have final velocity, this one doesn't have position, so they each serve purposes for depending on what you're given in the problem. We also had learned last year about what the graphs look like, and the AP, the College Board people like to focus on the graphing part of the equations of motion and what that looks like. So we're going to go through those real quick just to review. When you had no acceleration, the graphs looked different than when you were accelerating. You did have acceleration. So let's just recall that real quick. When you weren't accelerating, your position time graph was steady because you weren't, well, let's see. When you weren't accelerating, yep, your position time graph is like a straight line because you're not speeding up or slowing down, so your position is changing at a constant, it's going at a constant rate. Your velocity time graph was flat because the slope of this, which is 0, is going to be your acceleration, and your acceleration is 0. The slope of this graph up here, your position time graph, is going to be velocity. So whatever number your velocity is, that's what the slope is going to be up here. And then your acceleration time graph in that case, since there is no acceleration time graph, would just be 0. So right along this axis. Over here, your because you are accelerating, your position is changing its rate at which you're changing your position, so that's going to be a parabola. The velocity time graph is going to be a straight line, and it is true that the derivative of the position is going to be the velocity. So when you're doing this in calculus class, I'm sure you've seen this, the derivative of this graph is going to give you this straight line, and then your acceleration time graph is going to be flat, constant, where this number is the slope of your position time graph, because your slope is your acceleration for your, pardon me, the slope of your velocity time graph. The slope is the acceleration of the velocity time graph. So this number should be the same as that slope. So I just wanted to remind that to all of you. And then the last little thing that we had done was talked about gravity, and how gravity is this can be this force that's pulling everything down, but it can also be defined as the acceleration of an object towards the Earth. And we had talked about Einstein's theory of gravity, that gravity is really that dip in space that's caused by objects when they slide towards something more massive. And so this big massive object causes a dip in space, and that's what gravity is when you slide down that dip in space. The gravity of Earth was defined as a constant, negative 9.8 meters per second squared. Although I will tell you that on the AP test, they will allow you to use negative 10 meters per second squared for ease of calculations. So either one is fine, and they'll accept either one, and they accept answers when you use either one of those. The equations of motion stayed the same, so still those same equations of motion from up above. I'll just scroll back up to those again. Right here, these same equations of motion, except now you're going to take out the acceleration and place in the gravity. So just like that. Then you'll just use that gravity of negative 9.8 or negative 10. And then I just wanted to remind you that there was, you do have to, when you're dealing with this gravity and things moving up and down, you do have to keep in mind that the up direction is going to be considered positive, and the downward direction we consider negative. So if something's moving downward, it will have a negative velocity. If it's moving upward, it'll have a positive velocity. So that is basically a very fast review of what we did with motion. So I'm going to now have you go over to your problems packet, and you need to make sure you do all the questions on the front page. And then on the problems part, I'm going to ask you for tonight to work the following problems. This is on what I would call part 2, I guess. So you need to do all of part 1, which is questions. So do that part. And then of the problems, part 2, I'm going to ask you to do numbers 14 and 16 tonight. And then 21. And then if you turn the page, I'm going to ask you to do also, excuse me, 25 and 27. So if you can do those problems tonight after having watched this video, and see how you do on those, and do all of part 1. And then we'll go over these tomorrow in class, and we'll spend some more time on this worksheet.